Hello everyone, welcome back to another video. So today we'll discuss editorial for weekly contest 404, and I solved all four problems, but I had some penalties. My rank would be, I think, decent, but these two penalties can be avoided. This will, I would say, okay to this, but this could have been improved. The questions are interesting. I would say third question is interesting. Fourth one, I would say it is standard only. But yeah, third was more, I would say, thinkable than fourth. So let's start with first question. So in first question, we are given two integers. One is red, one is blue, which represents count of red and blue balls. And we have to arrange these balls to form a triangle such that first row will have one ball, second row will have two balls, and so on. And all the balls in the row should be same color, but in adjacent rows they should be different. Means first row will have blue, second row would have red, third row would have blue. So this alternate type of sequence should be there. And we have to return maximum height of triangle which can be formed. For example, in this case, let's say red are 2, blue are 4. So a representation of a triangle with height 3 would be like this, and we cannot create a triangle with height 4 because the balls required are not enough. Similarly, in second case we can make a height of 2, triangle of height 2, and in third case 1, and in fourth case again 2. You can see these diagrams and try to understand. Now constraints are very low as usual. This is first problem, so we are expected to write a brute force, but if mathematical solution would also be there, but I would say it might lead to penalties, so just write a simple brute force. Now brute force also, let's iterate from heights. I would say 100, because balls count is 100. We cannot make a triangle above 100. The number can be less, but let's just take upper bound as 100. And what I'll do, I will iterate from 100 to 1, and for each height I will check if I can make the triangle of that height. If I can make a triangle of that height, I will just return that height, else I will move to lower heights. Now how to check for any particular height? What would be the optimal configuration? So let's say I'm at height h and I'm trying to create a triangle like this till 1, and here there will be h balls, h minus 1 balls, h minus 2 balls up to 1. Now the colors for levels h, h minus 2, h minus 4 would be same. Let's consider it as red for now, and similarly for all the heights corresponding to h minus 1, h minus 3, h minus 5 would be let's say b. Now we can always prove that the this sum h minus 2, h minus 4 would always be greater than equal to h minus 1, h minus 3, h minus 5. And how can we prove that? Let's just take two cases where I have two cases. One is even, one is odd. So for even, if I can prove it for 6, I can prove it for 8, 10, all the even numbers. It's a simple proof, or it's simple assumption that I can say. For 6, I can first put 6 balls at bottom. So 6, then 5, then 4, then 3, then 2, then 1. So required starting balls would be 6 plus 4 plus 2, means h minus 2, h minus 4. So this is 12 and second is 9, because, and what I can prove is the corresponding maximum value for each ball in each ball of sequence which is starting at h minus 1 will have a greater value, means for h minus 1 there is h, for h minus 3 there is h minus 2, for h minus 5 there is h minus 4. There is no any, not any proof, just basic intuition, I would say. Similarly, for case of odd, 5 3 1 would always be greater than 4 plus 2. So it is always optimal to put the maximum number of, let's say, if I have r and b values, and I will first try to put all the balls in height h. So I have to put the balls which have higher count. If r is higher, I will put r balls here. If b is higher than r, I will start with putting blue balls. So we had to just implement this brute force. So what I'm doing is I'm iterating from 100 to 1. I'm declared a temporary variables r1 b1, and initially what I have done is I have replace, I would say if b1 is greater than r1, that means the number of blue balls is greater than r1. I will just swap them. This doesn't matter because the color doesn't matter what color we are putting. We are not asked to put what color we are putting at any stage. We just have to print if it is possible or not. And then I'm iterating from I to 1, and if r1 is greater than equal to j, I will subtract it, else I will just break it, means enough balls are not there. And at each iteration I will swap r1 and b1, because first it will check for r1, then it should check for b1, then it should check for r1, like this. So this was first question. This, I would say there are penalties for this question, because if you try to use maths or some other stuff, that is unnecessary. Just write a brute force, I would say. It's better. So this was first question. Now okay, let's move to second. So second and third question are same, just there is an k, there is additional condition of k in this question, whereas in first type of that question the value of k was fixed and it was equal to 2. Now so in this question we are given an array nums, and we have to find a subsequence of nums such of length x such that it is valid. And what is the validity condition? That sum of consecutive elements in that subsequence mod 2 should always be consistent. So sub of 0 plus sub of 1 mod 2 should be equal to sub of 1 plus sub of 2 mod 2. And we have to return longest valid subsequence of nums. For example, let's say this case 1 2 3 4, and now if you try to take in this case this whole array is can be one valid subsequence. Why is that? Because 1 plus 2 mod 2 is 1, 2 plus 3 mod 2 is 1, and 3 plus 4 mod 2 is 1. So all the sum consecutive sums mod with 2 is conserved in the whole sequence. Similarly in this case 1 2 1 1. So in this case, subsequence would be 1 2, then again 1, then again 2, then again 1, then again 2. You might understand this pattern where the sequence is an alternative sequence. Alternative sequence means the two elements are repeating continuously. Now, why is that? Let's say x, y, and z. So x plus y mod 2 is equal to y plus z mod 2. Now we can always expand this using the normal modular arithmetic. So first of all, x mod y, x mod 2 plus y mod 2 whole mod 2 equal to y mod 2 plus z mod 2 whole mod 2. Now, what are the possible values of x and y? Now, instead of x and y, let's just call them a, b, c now. X mod 2 is a, y mod 2 is b, and let's call this as y plus b plus c mod 2. Now, these two values should be equal. Now, we know that after taking mod, the value would be less than 2. Means x mod 2's value would be less than equal to 1. Means what are the possible values of a? 0 1. What are the possible values of b? 0 1. And what are the possible values of c? 0 1. Now let's try to put all the values of a and b and try to find the values of c. It is an three unknown variable equation, but putting two values will give answer to third variable. So what combinations are possible? So let's say I put a and b as 0 0, both of them to be 0. What will be the value of c? Value of c would be also, so this is 0 0 equal to c mod 2, so c would also be 0. Second is 0 1, and similarly 1 0. I can put any of this, and for this case 1 would be equal to 1 plus c, so 1 should be equal to 1 plus c, so c should be 0, and in case of 1 0, c should be 1, and in case of 1 1, c should be 1. So understanding this pattern, we can say that the first and last element is repeating, first and third element is repeating, while as there, because of this condition, because of this equation, so first and third element will remain same. Similarly, first and third element will remain same. So this is the proof of alternating sequence. So if there is a subsequence, it would be an alternative alternative sequence. So what, let's say I have a subsequence of length s. It would look like this: x comma y, then again x comma y, then again x comma y. Now here x can also be equal to y. Now possible combinations in for this question were limited, so x and y's value can be 0 0 0 1 1 0 and 1 1. So for that, let's start with that solution. And also the possible value of uh, the if the subsequence starts with first element itself, we can get a maximum occurrence of this alternative uh, subsequence. That means 0 1 or 1 0, because if something is starting from first index as 0 1 and there is already 0 and 0th index, we can start from 0th index itself. So basically we have to check for maximum zeros, maximum ones, and an alternating sequence of 0 1 or 1 0. So for that, what we have done is I have declared an answer variable current mod 2, and I have also declared an occurrence for storing frequency of 0 1. Now what I'm doing is I'm iterating, and this if is for checking alternative subsequence. That means if a of I mod 2 is not equal to CNT, means not equal to previous mod 2 value, I will increment answer and just make CNT equal to 1 minus CNT. So basically changes mod. If it is 0, it will become 1. If it is 1, it will become 0. And also increase the occurrence of a of I mod 2. And finally I will return maximum of all three values. So maximum of continuous zeros, maximum of continuous ones, and alternating sequence. So any uh, all three are valid subsequences, I have to just return maximum from it. So this was the case in second question. Little bit not tricky, I would say, but easy understanding this alternative object. That subsequence will be an alternate subsequence is important observation, I would say. Now third question is similar to that, but here the value of k was 2. Here value of k is given, means it is variable, it is not same. And what is the problem here? Problem here would be the number of possible combinations of alternative sequence. So for, let's say, if I have k equal to 3, all possible combinations would be 0 0 0 1 0 2, then 1 0 1 1 1 2. So possible combinations would be k square. Now writing a k square into n type of solution, let's say I know two variables, then I can greedily iterate over the array and find the maximum alternative sequence. And if you see the constraints for this, n is 10 raised to power 3, k is 10 raised to power 3. So possible solution is only k into n. K square n would not work. So how can we represent this state into a singular state instead of double state? That means 0 0 0 1 0 2 1 0 1 1. So I have to represent this uh, 2D state into singular state, and after representing into that singular state, I would also should be able to find answer. Now how can I do that? So there we can use sum of these values. That means this alternative sequence uh, means these two values, let's represent its sum as 0 1 2 1 2. Now this sum would be less than 2k and greater than equal to 0. Now for each sum we can calculate the maximum subsequence. How can we calculate that? So let's say for 1 and 2 I have sum is 3. Sum is 3. So when I am at a state where the mod value with k is 2, I will find its previous 3 minus 2. and what I will do for that, I will store its previous index and create a state where I'm include the subsequence till this would be subsequence till this plus 1. So a DP state would look like this. So DP of I would be equal to DP of previous of sum minus A of I plus 1. So first of all, we change this 2D state into singular state with with its sum, and for each sum we just need to store for each sum we will check what is the maximum subsequence using DP, and for additional with DP I also need previous vector which will store previous index of all the elements. So let's see the code. First of all, what I am doing is I am just changing all of A of I with A of I mod k. Now what I will do is I will iterate from 0 to 2k. What this I represents? I represent sum of those two values which are continuously repeating, which are forming their alternative subsequence. Then I have declared two vectors. One is DP vector, another is previous, which stores previous index of that element. First of all, I will initialize base case would be DP of 0 equal to 1, and previous of A of 0 is 0, means previous index of A of 0 was 0 for all the states of all the indexes which are coming after that. Similarly, I have declared a max variable which is storing the maximum subsequence length till now. So then I will iterate from 1 to n. I will calculate required. So if my sum is 3 and current element is 2, I will find its complementary value, which is 3 minus 2 1, and 1 2 1 2. So for finding this type of subsequence, for 2 I will find previous 1, for 1 I will find previous 2, for 2 I will find previous 1. So this can form a continuous subsequence. Required would be I minus E of j. Then I will just check if it is uh, of valid. If it is valid, that means it is 0, not negative, not greater than equal to 2, greater than 2k. And if it is not initialized, means I haven't encountered any variable. I have encountered them. Not equal to minus 1 means I have encountered that value. I will update dp of j with dp of prv previous of required plus 1, and it also we can also initialize dp of j as 1. So if it is the first element and we don't have any previous, so I have to also initialize it with 1, and then I'm just taking max with mx with dp of j for storing subsequence length and just updating previous element, finally taking answer with max. I hope you understand this. This was tricky, I would say. This type of observation that would not come that easy. So this was the third question. I would say this was more difficult than fourth. Fourth is just standard tree problem. So in fourth question, what we are given is we are given two trees, undirected trees, and we have to connect one node of first tree to another node of second tree with an edge such that the diameter of resulting tree should be minimum. So for let's say first example, In first example, tree is like this. And second tree is just this. Now I have to connect any of the node from first tree to any of the node to second tree, and such that minimum diameter is there. Now if I just connect this one to this one, so diameter would be 30110. What is diameter? Maximum distance between any two nodes. So if I join this 1 and 1, the diameter would be 4, because distance is 1 2 3 4. Now if I just remove this now and join this 0 and 1, now diameter would be 3, because if you try to find maximum distance, it would be 3, and it would look like 3 to 0, then 0 to 1, then 0 to 1 to 0. So what was a minimum possible diameter? 3. I cannot make any less diameter. There is no other configuration which can generate lesser diameter than 3. So answer here was 3. Similarly, you can try for this case. Explaining this tree would be difficult, so let's start with basic problem. What is the basic problem here? Find how to find diameter of a tree. First step. So first step, let's say I have a tree, single tree, not even first we will understand how to find diameter of undirected tree, then we will discuss the problem further. So this is the tree 0 1 2 3 4 5 6 7. Now you can easily understand that diameter would be from 7 to 5, from left node 7 to 5. Now how can we calculate it? The height of tree will always be a part of diameter of tree, because from that node which is at the last of the path which is forming height would also be the, what I can say, farthest element from all other nodes. Now in this case height of tree was 5 or 4 or 5, whatever we consider, and it would be 0, it would be on the path 0 1 3 6 7. So this would be the height of tree. Now from this point, whichever is the farthest point would be the diameter of tree. Now this is the standard problem. So what we have to do is, first step for finding diameter, first find height or farthest point from root. So farthest point from 0, you can find this using DFS, BFS. So I found that 7 is my farthest point from root. Now second step, find farthest point of that point. So I have to find farthest point of 7. So from this 7, I will again run DFS and find 5 as its at as the node which have longest distance from 7. So it would be 7. Now if I join a point on 1, let's say, so I will again copy this tree. So 0, 1, 2, 5, 6, and 7. Now 7 and 5 are two farthest points which are forming the diameter. They can also be different, means there can be multiple uh, there can be multiple pair of these farthest points, but considering only one is enough. Now let's say I connect a new tree at node 1. What would be the diameter of resulting tree? It would be distance of 1 from 7 plus distance of 5, distance of 7 to 1 plus uh, similar concept of any node in that second tree. So for 1, I have to the diameter which will be contributed by first tree would be distance from 7, max of distance from 7 and max of distance from taking max of both the distances. So for 0, let's say I connect another tree. So what diameter it the first tree will contribute? 1, 2, 3, 4. So for from 7 distance is 4, and from 5 distance is 2. So it will contribute max of both of these distances to the diameter. So I have to repeat this process for both the trees. Find the max of this for first tree. Similarly, any node of second tree which has minimum value of this max value. So for max f1, f2, I would say f1, f2 are the points which are forming diameter in that second tree, and its distance from f1, f2. So max of both values plus max of these both values should be minimized. So this was the solution. Now is also an edge case where this diameter itself is greater than this sum. So we also need to handle the both that two cases. So we will just see the code. Now this is just I can erase this. First of all, I am declaring mx. So mx is ignore this for now. I will just explain it for at last. Now first of all, there is one edges and second edge list. First I will calculate answer for first graph, first tree. What is the answer? So this value for each node, minimum of max of its distance from two farthest points, means the points which are forming the diameter. And how can I calculate it? First of all, I will create adjacency list. Using BFS, I will find the farthest point from root from 0. So it would be stored in LST. Now from this LST variable, I am finding LST2. So farthest point from this LST and I will store it in LST2. Similarly, in this BFS itself, I will also find distance from LST to all the nodes. So LST with itself would be 1. I have considered it 1, but in formal way you can make it 0. Answer would slightly change. You have to just write +1 here if you make it 0, but I just considered 1. So now in dist I have stored all the distances from LST to all other nodes. Similarly in dist2 I am storing all the distances from LST2 to all the nodes. Now I will iterate over all the nodes and find minimum of max of both the distances from first LST1 and distance of that node from LST2. Now one of the answer would be sum of both the values -1. Means from first tree, let's say diameter is there, so for 1 there is according to my answer it would be 4 for one node, and for let's say here it was coming out to be 3. Now as I have considered the distance of that element to itself as 1, that's why answer would be 4 plus 3 minus 2. So cutting this one from both the trees, +1 because this age is added. So overall comes to be 4 plus 3 minus 1. So answer plus answer to -1. Now the case of MX, that means the single tree itself has higher higher diameter than this merging. So for that I have declared a MX and I am passing it with reference to both the trees, and I'm just taking max with the diameter of that separate tree itself, and finally returning the max of both the answers. So this was fourth question. This is a standard question. I would say code is also very implementation based, but logic is very simple. So this was fourth question, and I think that's it from my side, and thank you for watching.